Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you another code review on this Good Cardio, Good Fitness data set. The reason why I'm doing the Cardio Good Fitness data set is because I watched this video on YouTube called Statistics for Data Science, Probability and Statistics, and this is one of the data sets that he covered. And since he covered the data set in the course, I thought, well, it would be a good idea for me to go ahead and go through the data set, which is what I'm doing. So I've got this data set on Kaggle, so you can find it on the Kaggle website. It's called Good Cardio Fitness. And I'll go ahead and go through the video review. So this is your problem statement. The market research team at AdRight is assigned the task to identify the profile of the typical customer for each treadmill product offered by Good Cardio Fitness. The market research team decides to investigate whether there are differences across the product lines with respect to customer characteristics. The team decides to collect data on individuals who purchase a treadmill at Cardio Good Fitness retail store during the prior 3 months. The data are stored in the Cardio Good Fitness CSV file. The team identifies the following customer variables to study: products purchased, TM195, TM498, and TM798. Gender, age in years, education in years, relationship status, single or partnered, annual household income, average number of times the customer plans to use the treadmill each week, average number of miles the customer expects to walk or run each week, and self-rated fitness on a 1 to 5 scale, where 1 is poor shape and 5 is excellent shape. Perform descriptive analytics to create a customer profile for each Cardio Fitness treadmill product line. So that's your problem statement. So import libraries is, we're importing NumPy, which is a fast library for Python that forms numerical computations, linear algebra, and it also creates NumPy arrays. We're going to import pandas, which is written on top of NumPy, and it does data processing and creates data frames. We're going to import OS, which goes into the operating system and retrieves the files that we need to use. We're going to import Matplotlib, PyPlot, SPLT. That's a graphics library that it plots all the data points onto a graph. And then we're going to import Seaborn as SNS, which is another graphics library written on top of Matplotlib, which performs statistical functions as well. So we're going to use OS library to retrieve the operating system from the file. So you can see that there's one file, the Cardio Good Fitness CSV, which we're going to retrieve. We're going to read the program we're going to read the CSV file into the program, and we're going to convert it to a data frame, which is what we've done. And then so we say product, age, gender, education, marital status, income, miles. And I think what I'm going to do is I'm going to shuffle this when I finish the code review. I think that's a good thing to do, is to shuffle it. We're going to check for null values, and we don't have any null values. We're going to analyze the data. So there's 180 rows of data, and then what we do is we're going to describe it, and when we describe it, we're going to say include all, so it will include the categorical, it'll include the object columns in addition to the numeric columns, so you can see what's going on with the object columns as well. Okay, so we're going to do a histogram on the entire data set. So the entire, and this is just going to include the numerical values, numerical columns of the entire data set. So we've got a histogram of age, education, usage, fitness, income, and miles. We're going to do a box plot on gender and age, and it looks like you have slightly more males than you do females. We're going to do a cross-tab of product and gender. So it tells you, so you have more males buying the product than females, except for the TM195. We're going to do a cross-tab on product and marital status. And you have more partnered people buying the products than single people. We're going to do a count plot of the product and gender. So you see that you have equal number of people, males and females, buying TM195, but you have more males buying the TM498 and the TM798. We're going to have a pivot table where it divides the three products. So you can see what it looks like on the pivot table. And it divides them into gender as well. It divides it into product and gender. And then the columns are going to be marital status. So we're going to do a pair plot. And then when you do a pair plot, what you do is you plot out all of the columns. So we plotted out the age, the education, usage, fitness, income, and miles. So we're going to do some statistics. We're going to do statistics on every column that's numeric. So we're going to calculate the STD, the mean, the maximum, the minimum, the var, and the covariance. And one thing that I found was interesting is the variance and the covariance give you the same value. So I'm not sure exactly why that is. I will have to research that. And then we do a disk plot of age, which we've already done before. And we do this with every numerical column. So we do the same thing with education, usage, fitness, income, and miles. And then so we do a disk plot on miles. And then what we do is we create a heat map. And when we create the heat map, we check the correlation between the numeric columns. So you can see if it's a 1, it has a high correlation. And if it's a 0, it has a low correlation. And then we do our heat map. This heat map is only on the numeric columns. And so you can see the ones that have a high correlation and low correlation. So now what we're going to do is we're going to filter out the treadmills on TM195. You filtered that out. So you've got a data frame just for the TM195. And then so we've got a description of the TM195. So it tells you how many rows of data relate to the TM195, and it also gives you the statistics for the TM195, but it doesn't give you the variance and the covariance, but it gives you everything else. Then we check the TM498, and we describe the TM498, so you have 60 rows of data for the TM498, and it gives you all the statistics for that. Then we do the TM798. You have 4 rows of data, 40 rows of data for the TM798. Okay, so now what we're going to do is we're going to employ some feature selections. And since this was a statistics course that I was taking, or I viewed the video on YouTube, he did feature selection. So we're going to do feature selection with all of the numeric columns. And with all of the numeric columns, you've got like the accuracy for the X train and Y train is 0.735. And then you've got the coefficient and interception. The coefficient is right here. You can see the coefficient here for each column of data. And then the interception is 24. And this is your accuracy for the train and test. And this is your mean squared error, and root mean squared error is 61. And one thing that you'll notice as you go through and we delete features, whenever we delete features, our accuracy decreases and our error increases. That's one thing that you'll notice. So you have the best accuracy when you have all of the features, and the least error when you have all of the features. So that's it. I think what I'm going to do is I'm going to go back and I'm going to shuffle this data set, because I think that the different columns of the different products that are being used are not shuffled. And I'm going to see, if I shuffle it, how that's going to affect the accuracy. But that's it. That's it for the code review of the cardio fitness, of the cardio good fitness data set. And you can get it on Kaggle, and you can look at my data set if you like. And it's always good for me to do a code review on YouTube, because when I do a code review on YouTube, at least I can find things that I've forgotten to do and correct that before it goes live. So thank you so much for watching my video. I would like to thank all of my subscribers for supporting my channel. And if you like my video, please like, subscribe, and share. Goodbye.